Alright guys, so the next topic I want you all to go through for the next 2 days or so is the difference of two perfect squares, right? So before I even start to break this down, man, have a difference, let's have a subtract sign, right? Two, so you're looking for two things that being subtracted, and each of them must be perfect squares. That is the difference of two perfect squares. Most of the time, these questions will look exactly the same. Literally, it really don't change. Alright, so examples of perfect squares before I even start. We know 4 is a perfect square. Why? Because the square root of 4 is 2. A perfect square is basically any number or any term that has a perfect square. Right? So 6 is not a perfect square because the square root of 6 is not a whole number. So square root of 6, so therefore 6 is not a perfect square. So if I had something like 9, 9 will be a perfect square because the square root of 9 is 3. 16 will be a perfect square because square root of 16 is 4. What else? What else you have? 25. Is 25 a perfect square? Yes, because the square root of 25 is 5. We also have 36. Square root of 36 is 6, and you go down to 49, 64, 81, 100. All those numbers are perfect squares because the square roots of them are perfect numbers or whole numbers, if you want to call it, not decimal or anything, right? So, with that said, you know what are numbers. So, you know the perfect square for the numbers. The next part that you need to know how to get the square roots of, apart from the numbers, is stuff like this. So, say I have a squared. So the square root of a squared, remember this, right? The square root of a squared is a. Okay? If you have like a to the power of 4 now, the square root of a to the power of 4 will be a squared. So basically, all you're doing, the number on top, the square root will just be like two things have to add up to give you that number on top. So if I'm looking at it, a to the power of 1 multiplied by a to the power of 1 is a squared. Same thing, a to the power square multiplied by a squared is a4. Because remember, when you multiply stuff, sorry, you add the powers, okay? So in this case, the square root of a squared is a because a to the power 1 by a to the power 1 is a to the power 2, which is the square root we try to find. The square root of a to the power 4 would be a squared by a squared. Why? Because 2 plus 2 is 4, okay? Now let's try the next one. Remember a squared and a4, because those are the popular ones, okay? Square root of a squared is a. Square root of x squared is x. No matter what letter they use. The next thing they could bring, say they bring a to the power of, say, what they could bring 8. So we know a, so you square root of, so it would be a to the power of 4 by a to the power 4. You know, says that these numbers on top of it be the same, right? So if I just square root of, say, a to the power of 9, this will not be, you can't get the square root of is a to the power 9 because no two numbers added together can give you 9 that are the same. So you can have 2, so 2 can be 1, you can have 4, you can have 6, because 3 plus 3 is 6, you can have 8, 4 plus 4 is 8, you can have 10, 5 plus 5 is 10. Right, but the most popular ones, as we break it down, the popular ones, remember this one. X squared, square root of x squared, first squared, it would be x. This letter here could be any letter. It could be z, y, square root of b squared. Anything squared is just b. Okay? So putting everything together to do these types of questions, it will look like this. So break it down. So it will look like 4a squared minus 16. Questions will look exactly like this. It don't really change. So the break it down is the difference of two perfect squares, right? Everybody 6. So watch it. Watch how I'm gonna break it down so you can see. So the first thing I'm looking for is that difference. Can we see the difference? Well, look at here. Difference. We see any subtract, so the difference. Are we seeing two things? Well, yeah, we see in this here. We see in this here. Those are the two things. Yeah? So now, let's look at the two things properly. Alright, those are the two things. So you're seeing one and two numbers. So those are the two things. But are those two things perfect squares? That will determine whether there's a difference. We see in subtract 2, we see in two things, but are they perfect squares? So let's see. So we know to file for something as a perfect square, we could just square them and see if we get a perfect number. So let's see. So the first step was the square root of this, and was the square root of 16. Okay, so we know the square root of 4a squared. Let's look at them individually, right? So the square root of 4 is 2, and we know the square root of a squared is just a, right? So therefore 4a squared is a perfect square. And well, we know the square root of 16 is 4. Okay, so we just work it out. So you just find the square root of two of them. Alright, and now to get the actual answer, which is the easy part, these things here kind of answer. So one bracket, you have two of them, but you add both of them. And then the next bracket, the same two, but you're just subtracting them. And that is it. So the first step, the difference of two perfect squares look exactly the same, literally. Difference, subtract sign are two perfect squares. The first thing to do is square root both of them. So you see how I square root them? And then when you get the square root, you find what the square root is at the bottom. And the actual answer will be these two things. One bracket, you add them together. And the next bracket, you just subtract them. Okay, so I'm going to do our next one so you can see. There's the last one. So if we had 9, if I had 9a squared minus 4. So I say that. Going through these steps, first thing, we square the two things we need the perfect square them. Because notice perfect square, they look the same, and the when we bring a question are different, right? Okay, if they add one more term, it will be three things, so it can't be a difference of 2. Yeah? So first thing is square both of them. So you square them. So is square root of 9 is square, remember I told you to square both of them separately and put them together. So the square root of 9 is 3, and the square root of a squared we know is just a. And then the square root of 4 is 2. So the answer, as I said, one bracket will be adding together, so it'll be 3a plus 2. And the next one, 3a minus 2. It don't matter whether you put the minus or the plus, it don't matter. Once you put one bracket, you add them together, and the next one you subtract them together, you get your marks. Okay, so one more. So we could have 16a squared minus 25. So we see now difference, correct? 2, yes. Are they perfect squares? So let's see. So you know, square root, first step done. Now what is the square root of 16? We know is 4. And what is the square root of a squared? We know is a. And now we go on the next side, the square root of 25 is 5. So we know the answer, one bracket to be added together. And that bracket we just subtract. Okay, and with that said, step 1, square roots. Step 2, find the square roots of them. And step 3, put them together. The general form of the answer is like this. So you have one number, you subtract, next number, then one number plus the next number. Okay, you could just fill in the values with that after you get the square root of them, right? Prepare plus or minus here if you want to. That's actually what I do. Alright, so, and that is the difference of two perfect squares. Alright, so be safe. We'll talk.